Hey, hello and welcome to the show. It's me, John Park, and here we are with John Park's workshop. First of all, I want to thank everyone for stopping by. We've got a bunch of great people over in our chat. If you're wondering where the chat happens on these shows, it's over on Discord. So go to Adafruit's Discord server. That's adafruit.it/Discord. You'll get an instant invite. Head on over there and check out the live broadcast channel. That's where we've got some good people hanging out. And so what I want to do next is ask for your feedback on my audio, because I had to do a slightly different setup today than I usually do because of some audio stuff we're going to be doing later. And so what I'm hoping is that we don't get any feedback and weirdness. So sounds like C. Grover in the chat says the mic is sounding great, peaking at -6 dB, which is excellent. And I'll ask you later when I turn up the second sound input how things go. So thank you. Thanks for watching out for that for me. Let's see what else is going on. We have hopefully a smoother show in store today as far as the bits traveling through the internet, because I have dropped the resolution of the show. Hopefully you didn't notice, but I'm dropping it down to 720p instead of 1080p, just because we were hitting a lot of speed bumps in the encoding, heading through Restream and into YouTube. I'm not sure where the bottleneck was. Could be my internet provider. Who knows? But this is an experiment in seeing how smooth it is. It looks like so far my dashboard in YouTube is saying excellent connection, which, hey, that's nice, because that's not the sort of thing it was saying to me last time. It was all angry. All right, well, let's see. Before we go any further, I want to mention some little housekeeping items, such as our jobs board. So if you head on over to jobs.adafruit.com, you can check out our jobs board. We've got all kinds of positions posted up there by people who are looking to hire perhaps you. I know it's not polite to point, but perhaps you. Do you know that's how they point at Disney? Oh, you can't see it. I think it's maybe 3 fingers and the thumb. Maybe that's an inoffensive gesture. I don't know. Got gaffer's tape on my Band-Aid today, by the way. The Band-Aid wouldn't stay shut. If you head over to Adafruit's jobs board, you can post your resume if you're looking for work, and you can also look for jobs. It's all free. All you need to do is log in and with a Adafruit login, and then you can use it for all of your job hunting and people hiring needs. And that can be freelance work, it can be full-time, part-time, contract, remote, on location, all sorts of possibilities. All right, let's see what else. I've got this show that happens on Tuesdays. It's JP's product pick of the week. That's the little logo right there. And on that show, we spend about 15-20 minutes looking at a new or favorite product. Sometimes it's an oldie but goodie. Sometimes it's brand new. Sometimes it's in between. And this week, I looked at the Itsy Bitsy RP2040. Not to be confused for Blade Runner 2049, but maybe I'm adding to that confusion. I don't know. Okay, I do know. And one of the cool things is you will usually get a pretty significant discount on the product pick of the week. This week it was 50% off on those Itsy Bitsy RP2040s. And then I like to do a little demonstration of the product in action, as well as a recap. And that's what you're going to see now. This is a little 1-minute excerpt. It is the Itsy Bitsy RP2040, a powerful little board. We've got lots of flash on there, lots of GPIO pins, can do CircuitPython on there all day long. And I'll show you a little project that I put together, because you may ask yourself, well, what kind of project would I want lots and lots of GPIO pins for in a small form factor? So you can see I've got my little Itsy Bitsy plugged into a small breadboard there, and then I'm breadboarding these wires into a key bed that I pulled out of an old synthesizer. It's an 8-column and 8-row diode matrix. So that means I need 16 pins plugged into my Itsy Bitsy. And I have some leftover pins that I decided to plug in a little NeoPixel strip. Using our keypad library, I can read the diode matrix and know which keys I'm pressing. I decided to have it send off MIDI commands and at the same time send commands to my NeoPixels to light up. It's the Itsy Bitsy RP2040. All right, yeah, so let us know what you do with yours. I tell you, the Itsy Bitsy is a really cool form factor. I love how much GPIO it's got and its small size. So I'd love to hear what kind of projects you dream up with yours. All right, so how about next up, let's dive into our CircuitPython Parsec. Yeah, let's do that. CircuitPython Parsec. All right, wrong window, hang on. That's the one we want. There we go. All right, let me get this set up here. Oh no, someone said audio is out of sync. Is this audio out of sync now? I'm gonna wait to dive into this for a second to see if we have any audio sync issues. Hopefully not. It looks clear on this end so far, but yeah, oh look, yeah, there's YouTube saying that it's having an issue. Okay. Well, I'll tell you what. I am going to kick the broadcast button. Hold on one second. All right, so that is my server restarting there. And I'm going to let it cook for a second before we get too much further. You let me know how the sync is. The other thing is I am recording. Oh, good. Okay, back in sync. That's what people say. Am I getting messages about this very thing? I am. All right, good. Seems like we're back. Thank you for the warning. Thanks for letting me know. All right. Let's get this ready. I'm going to bring up my Atom window right here. Where'd you go, Atom? That's my little coding environment there. And you know what? I am going to tempt fate and fix something on the fly, which is the size of this window. Could be improved. So let me just do like so. And here it comes. Yeah, that's a little bit better. Okay. Are you ready? I think I'm ready. For the CircuitPython Parsec today, I want to show how you can create a color helper module. What is this all about? Well, when I'm using NeoPixels, I have certain colors that I like to use a lot. I want to reuse these colors, and rather than just copy and paste them from some document into my code, what I've done here is created a separate file. It's a separate module, and you can see it right here. It's just called jpcolors.py. And in this, I have defined a bunch of colors that I like to use. So red, green, blue, you'll notice they're pretty much solid colors, but not as bright as just going full-blown 255 or FF if you're using hex like I am here. These are a little dimmer, which helps with evening things out, and some of them are dimmer than others because of sort of gamma issues. You'll also see here I've got this amber color that I really like to use a lot, and it's not one that I typically remember, hey, what exactly is amber? What's a good formula for that? So once you've tuned those and dialed those in once, you can save those variables in a class here. And this class I've created is called color. I've defined a bunch of color values, and then I save this as a separate module file on my CircuitPython device. Then you'll see inside of my code.py, when I want to use that, I'm simply importing it right here from jpcolors, import color. So that imports that class from that module file. Then, whenever I want to use colors, I can just simply call them by name down here. So I've created this little function called chase that creates these nice little chase effects. And the only input that I have to that is what color chase are we going to do? So if I want to use my amber color, then I say chase color.amber. And the rest is taken care of for me. So I have cyan, magenta, red, black, and white here. So black is really off, but it's easier to think of it that way. And so that is a really simple way that you can create some variables that you want to reuse all over the place in a separate file. And that is how you can create a color helper module inside of CircuitPython. And that is your CircuitPython Parsec.
CircuitPython Parsec.
Yeah, look at that beautiful amber color. That's one of my favorites. It kind of feels like an old analog bulb sort of look, a very, very warm analog bulb or neon indicator bulb kind of look. So I dig it. All right, let's see, what else? Let's dive into some new territory here today. So I'm gonna bring up, let's talk about, okay, so we got a couple things I want to do. Let's talk about this. You ready? Getting ready. So the project that I was working on last week, let me switch out what I've got under the down shooter here, was this 4x4 keyboard. Show it to you right there. Okay. So this is one of our Ortho NeoKey snap-aparts. You can see it back there under the frosted window. And this is a QT-Py M0, and I've put some jade switches on it, and I've got some nice little windowed keycaps. You can see their little LED flying across there. And I'm going to go ahead and set this under my camera and refocus that for you. Let's have a look here as I do that. Bring that into better focus. That's pretty good. Yeah, we'll leave it like that. Okay, so the code that I've written for this, I just published it and I'm working on a guide for this. This is done in Arduino. And the reason I chose to use Arduino in this case instead of CircuitPython is that I'm using the Itsy, or not the Itsy, the QT-Py M0, which just is so constrained for space that I wasn't going to be able to put the keypad library, MIDI, and some of the other stuff that we needed on there. So we went and said hello to our old friend Arduino. And what I'll do is I'll show you first of all, here's what I'm running on there, and then we'll talk about what it does and how it does it, and I'm going to give you a bit of a backgrounder on driving a modular synthesizer. It'll be a software modular synthesizer using this code. So let me open up my Arduino window here so I can see it. Where are you? There you are. Okay, so what I'm doing in here is I'm importing the tiny USB library, which is really nice, allows me to work with USB MIDI really neatly. I'm importing the keypad library, so that Arduino keypad library works an awful lot like the one that Dan wrote in CircuitPython. Then I've got NeoPixel and I've got MIDI. Now, you'll see here I'm setting a couple of user variables, actually 3 of them that matter a lot. Oh, and I will pause and stall for a second while that comes back into play. Well, that's really frustrating. I was hoping that dropping the bit rate of this was going to fix issues, and it seems to have caused some different ones. There's also a possibility. I'm running, maybe ill-advisedly, I'm running VCV Rack, which is a resource-heavy program in the background, but this does not seem to be acting like a computer resource issue so much as an internet resource issue. So we'll see. So that should be back up and running and hopefully back up in sync, and I'll wait. And I can't remember if I mentioned, but I am recording this also to disk so that I'll be able to have a clean synced version if necessary, if we need to republish this later. Been sounding completely fine, but the video gets iffy. Huh. All right, there's one other move that I can try next week, which is to change the canvas size. All right, so looks like we're back in sync. So in my sketch here in Arduino, you'll see I've got a variable here called Latch Mode. And on the keypad, I want it to be able to either latch keys, which means I press them and they light up and they're doing something and they continue to do something, or have them be toggle, sort of momentary. So right now I have it in this sort of toggle or momentary mode. you'll see I've also got the beats per minute. So we can set the beats per minute of the program, and that means that this little blinking that you're seeing going by here is set to a certain tempo that my music is gonna be working in. And then we also have a MIDI out channel, so we can send this to different channels. The next thing I do is I have a little bit of math to get me the beats per minute by dividing the beats per minute, or rather dividing 60,000, which is the seconds, by the beats per minute. So 60,000 seconds in a minute. I'm setting up my MIDI device here. I'm setting up the keypad to be 4x4, 4 rows, 4 columns. And then I've got the pads that these are going to be playing. So this is a sort of remapping of if I press key 0, it's going to play MIDI note 57, which is an A. And so I've got a couple of octaves of a little A major scale plus a little G sharp thrown in for style points. Then we've also got a pixel order remapping because the NeoPixels run in a snake pattern, but the grid is a grid. And then what's happening in the main body of the code is that we check keypad to see if any of the buttons have been pressed. When they've been pressed, we will then look and see if we're in toggle mode, then it's just going to, if we're in toggle or momentary mode, I should say, it'll just play the note and then release, turn off the light. If we're in the latch mode, then it's going to hold that and keep the color. And then the last thing I have down here is in my little sort of clock that's ticking at the tempo of the beats per minute, I'm sending a MIDI clock signal so that MIDI software can read that and do something with it. And I'm advancing my little red LED across. So let's look at a better view of that actually here. And I can pull the extra me out of there. There we go. So here you can see this is ticking along at 120 beats per minute. And what I'll do now is, this is where audio could get super iffy, but check it out. Let's turn up. All right, so let me know if you can still hear me and the sound, because I can mix that a little bit here, or a lot here if we need to. So here's the scales I have. It's essentially 2 of the same scale. And then the same one repeats. Now, there's a lot going on there. Thanks, James Foe says, good mix, appreciate it. That's good news. There's a lot going on in the synthesizer side of things that I'm going to show in a second. And particularly interesting is some of those effects that are dependent on the tempo. So there's a few reasons why we would want to set a tempo when we're playing the synth. One will be a drum I'm going to pull in. I want that to be in synced clock time. As well as some of these little modulations that you hear, these little tremolos and things. Those are happening also at the frame, the tempo, or some multiple or division of the tempo that we've set. If we want to check out for a second before I dive into that synth side of things, if we want to check out what happens with the latch mode being true, currently this is sort of an idea, a launching off point, this program. It is not feature complete. For example, it'd be really nice to hold down maybe the 4 corners and have that change my mode between latch and toggle, or some other arrangement to get into a settings mode where we can adjust the beats per minute. I don't have any of that right now. I'm just going to go and change that right here inside the Arduino sketch and re-upload it. So with more development time, of course, you can add a lot of really cool features, and I'm always excited to see if people take something like this and run with it and do some cool stuff. So uploading right now from Arduino, crossing fingers that that doesn't just bring the whole thing crashing down to the ground. It claims to be uploading. That's good. Uh-oh, an error occurred while uploading. What happened? All right, I'm going to double check my settings here before I try that again. Cutie Pie over tiny USB, and I probably had the wrong port. No, it looks like maybe the right port is picked. And how many other plugged in that could show up as Apple device. Let's right now? No, it's not. You know what? I'm gonna power off this guy. Let's see if it comes back up. Uh-oh, did I not plug it back in? Hopefully it's not a demo worst case scenario, which is I've now somehow bricked the thing. All right, it's compiling. That's a good sign. Oh, you're getting the max headroom effects. Uh-oh. All right, I'm going to pause here for a second. All right, I have just restarted it. So if you said that it was paused on YouTube, that is because I was sending them no data. So let's see if that kicks it back in. And while that's going on, I'll see if I can convince the board to come back to life. It is acting super, super bricked. I may need to get to the reset on there. Hold on. Thank you for your patience here. We've got multiple weird things happening. Yeah, okay, this is not showing up. Hold on one second. I am, so by the way, one flaw in my design I realized is I don't have a accessible reset button. So drilling a tiny hole in the back case there might be a good idea so that we can get at that reset on the Cutie Pie. It'd be nice if we could use one of the key switches as your reset button during startup or something, or through some key combo. But I don't know if you can tell the board to reset with anything other than the reset button. So let's pull this right here. Oh, okay, that's good. I see a sign of life. Let's try telling Arduino to re-upload to the board here. So if you don't know this, sometimes with Arduino, if it's having a hard time putting it into sort of the soft reset mode, you can double-click the reset button while it's getting ready to upload, and then it's more likely to find the port. So it looks like that worked in this case. I'm going to leave that back plastic off of there for now. So now, if that worked, oh, it's restarting. I think it's pressing the reset button. Hold on, let me lift that up and off for a second. Let's pull the little kickstand up. I think it was just sitting on the reset button. Hopefully that's all that's going on. So now when I press a button, what it should do is send the MIDI note on and never send the MIDI note off until I press it a second time. So this is the latching mode. So this is good if you want kind of a little background drone or something like that going on. So that's just going to hold those, and then if I want to turn one of them off, just press it a second time. Like that, okay. So what I want to do though is I want to set this back to temp fate and do it again. So I'm going to set this to false, change my latch mode, see if it's happier about that sort of soft reboot reset that it needs to do. There, it found it. I think you can see, hopefully you can see my little text down there. So the toggle mode now, non-latching mode, more like a typical keyboard. Right. So that's working now. So now what I wanted to do is, especially because it seems like we have a working stream. All right, let me know when this comes back in, if we're back in sync, and I shake my fist at streaming and internet. Yeah, I cursed it. I said, seems like we have a working stream, and boom, it froze. Okay, so if this is working again, what I think is, I'm not going to go into huge depth on this because I'm afraid we'll lose sync, but the sort of key things that I wanted to do, and maybe once I get this under control another day, we can do a deeper dive into this. I may use a setup where VCV rack is running on a separate computer and acting as a display output, because this could be causing some problems. I haven't streamed this in Wirecast before. But this is the setup that I have, which looks a bit complex, but the main things that matter, the main things that are going on, these are a series of modules that each have sort of discrete tasks that they do. And the first one here being this one called MIDI to CV. So that's what's bringing in, using the core MIDI driver. You can see right there, it says CircuitPython M0. So that's what this 4x4 here is showing up as to my computer as a MIDI device over channel 1. And you'll see when I press a button, that little gate icon is lighting up. Clock is always pulsing there, and the volts per octave is also sending out over these cables to a bunch of different places. So these cables are routing essentially a conversion of the MIDI pitch information into what's known as volts per octave. So in the modular Eurorack modular world, a volt is 1 octave, so partial volts equal the semitones that we can go through, or sort of non-standard scales. You can kind of sweep between any pitch you want using this voltage. And gate 2 is a type of voltage that's a sort of a square wave that just says turn on a voltage-controlled amplifier or turn it back off. So the fact that we hear something, and you'll see this little display over here called VCA. If I hit a bunch of them, you can see it a little better. All right, so that little VCA meter there, that little green meter, is opening and closing essentially an attenuator that allows the sound to come through. My clock is going through this clock divider and multiplier so that I can add in drums. So here you'll see this is going to be in sync with my 120 beats per minute. So that clock is in sync with the effects. The other effects I mentioned, I have some things like tremolos or little modifying modulations that are going to be, you'll hear them when I hold a note, and those happen also in time. Wow, 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 that kind of stuff is happening also at some multiple of my clock. That's why we want to be able to set things in sync. Also, it's kind of nice for me, at least, looking at the tempo marker going by on this little display here, and I just like it. It looks cool. It really shows off these type of windowed keycaps, of course. So we've got those neopixels on there lighting up. I think there's a little bit of a glare on there, but I think you can see that. And so I think that's hopefully we're still in sync, audio and video wise, and what I'm going to do now is actually get away from that window. I'm actually going to close down VCV Rack just in case that's been causing issues in the background there. So let me switch camera views here, and we'll say goodbye to VCV Rack. One of these days I will get my setup to be happy with that, test that a little more, and hopefully we'll be able to turn down that input there. Okay, so it's not going to try to bring in that mic. So let me know if you have any questions about that. Let me know, of course, if the stream is still happening and in sync. I do not see any angry messages from YouTube, so that's good. Now, okay, so on to the next thing. So next thing I wanted to do was just sort of kick off a project, and I think you'll like this because it's a somewhat of a continuation of last week's project, which is because when we don't want to waste anything, and when we took this, or I took this and turned it into, let me unplug this one, and turned it into this, I had to remove some of these strips of PCB keys there. So we went from the 6x5 down to the 4x4, which means I have a bunch of extra left over. So here, for example, is a little chunk of 5 that I've got. And what I want to do, let me switch over to the workbench here. What I want to do is turn that little extra there into some sort of a little mini Launchpad type of gizmo. So the case I want to use is this really neat aluminum one. Let me switch cameras out there. There we go. So this is a little aluminum 4-key case that we have in the store, have in the Adafruit store. So I'm going to need to bust off one of these. Let's see, what's the top? That's the top. That's the top. That's the top. So I can feed in my data for the NeoPixel from the top, my voltage, ground, and column, and then I'll connect to row, not my boat. So let's pry off a fourth one that I don't need, and you can see how this is going to lay in here. And this is designed to have your keys snap right in from the top. So this has the nice tight tolerance there. Let me zoom in a bit. So you can see, click, click. Those will snap right in there. And then we want to be able to click those into our little PCB. And then there'll be a little bit of wiring necessary, and we'll need a microcontroller in there. So I was playing around with this a little bit and found out a few important things. So this is, it's interesting. Lady Ada was talking on Ask an Engineer last night about the fact that it is awesome to start with your enclosure and then build your PCB and the rest of your project, because once you've got the enclosure down, you can start measuring things or get some technical drawings and make everything fit. In this case, I've got this enclosure, but these already exist, right? These little PCBs here. Let me pry up the one that I sat into there. These already exist, and there's a bit of a mismatch here that we're going to have to get creative about to make this work in this case. And the reason is this has a little acrylic, I haven't peeled the backing off of there, it has this a little acrylic base that goes on here, and that presumes a few things. That presumes that you've got some holes here for your screws to go into. It has little standoffs, little brass standoffs, and I went ahead and unscrewed one because these are actually threaded, I think probably for M2. These are threaded the same as the screw that goes into there, so we can actually start off by just gripping those with some pliers and do a little removal there. It's just a tight fit there, so it takes a bit of work to get that out. And there we go. Okay, so that will allow me to lay these flush. Flip it the other way. So without, if you don't remove these are just not going to fit because the mounting holes are in the way of this PCB. So that'll be step one. Step two, let's actually go ahead and pop in the rest of the keys here. And by the way, you could, if you had a sort of horizontal set of these, I don't anymore, I think I've snapped those all apart. You could use this sideways like this and have your LEDs at the bottom, but I'm going to just set it up vertically, at least for now. Let's see if I change my mind on that. Both are valid. Both are super useful ways to have a little macro pad. It, of course, work in either orientation, but if you want the LEDs at the bottom of the key or at the top of the key. That's going to work this way. So now these will gently press fit into the PCB. So that's good to go now. And you can see this is the clearance that we have. Oh, sorry, let me switch my view around there. This is the clearance that we have for a microcontroller. So either a QT RP2040 or a Itsy Bitsy. Those will fit in there great. In fact, I think this case was probably designed for a micro USB as far as the shape of that cutout. It might have been meant for one flipped this way. But you can see my fit there of the Itsy Bitsy is pretty good. We might put some Kapton tape to avoid any shorts there. But if that goes in like that, looks like micro USB cable fits in pretty nicely. Okay, but there's no way that this generic cover is going to happily still screw into place and hold all that with the screws that it came with. I've got no holes available for that, so something different is going to have to happen. And what I'm thinking of doing is 3D printing a little extension to this that will allow us to use the parts that we have here. So this is just a somewhat happy accident, this piece of 3D printed case that I had from a different project. Fits in there nicely, just kind of gave me the idea of what we could do, which would be add a little extension there that the Itsy Bitsy can fit in. We'll need a hole there so that the USB port still fits in place. And maybe get that, you can see I have one mounting hole that is still visible there. I might shave a little off of that PCB. That's in a non-critical part. Or it might come up with some other method. Maybe it's just a really good tight press fit. Maybe you just want to put some foam tape in there or something. But if we have a little extender like that, it doesn't have to be this tall. Just a little bit, just maybe a 2 millimeter extension on there would be enough to do everything we want. And then we can still use this pretty neatly. So that's the kickoff there of what I'm planning to do. And stay tuned. So that'll be some 3D printing and design that I'll do, and maybe we'll get into that on air. But for now, that's where I'm at with that. And if I get a nice easy method using a 3D printed part for that, I'll of course share that in a guide so that you can grab that and use your own. The reason, of course, for this being necessary is that these type of cases are really designed for you to make a custom PCB that has your microcontroller and your keyboard, key switch PCB all sort of built into one, designed to fit this space with screw holes and mounting and all that, and then this will fit on top of it. Or you could do some hand wiring of switches and just need to fit the microcontroller in there, but not a lot of space, so I'm going to extend that a little bit. So there you go. That's the idea behind that. That's the kickoff of that project. And let's see. You know, I'm curious to find out. Let's jump back over into the Discord. How are we doing on our sync? Can we sort of safely blame VCV Rack for hogging resources somehow? I think it looks like the stream is healthy. At least YouTube is saying excellent connection right now. So maybe that was not such a great idea on my part to have VCV Rack open on the same machine. I don't know. I think there's other people who stream VCV Rack stuff, so who knows what's going on. C. Grover says, nice switch case. Enough room left over for a piezo buzzer. Yeah, that would be a fun addition in there. Looks like some people are sharing their projects using the Ortho snap-aparts. There's a picture from Doctor about a little setup going on. Let's see. So there's a question here. Screwed up snapping my orthos apart, making a split keyboard. Forgot they were zigzagged, so now I have rows that are all out on one side. Do I need to not zigzag numbers in my NeoPixel matrix for the keypad? Let me see. Let me look at the picture here a little bigger. So from what I can tell, you just need to run one wire from the end of one row to the beginning of another row that's your NeoPixel out to your NeoPixel in. And then you'll be able to treat it as one. Is that right? Oh, no, wait. No, you're right. You're fine, actually. Yeah, the NeoPixel will run this way. So that should be fine. Unless you... Oh, I see. So you have some snap aparts there that I'm not seeing. Okay. Yeah, so just run your NeoPixel out to your NeoPixel in at one end, and then it will do this, this sort of U-turn shape. And you do need to solder all your V-ins coming down, all your grounds coming down, all your columns coming down, and then you'll go into the rows on the side of it. So you can probably look at the example fritzing that I put up for the numpad 4000, because that one I had some break apart situation. And hopefully we're back, and hopefully back in sync. So yeah, boy, that's frustrating. I don't know what the heck is causing that, because it apparently is not our VCV rack. Ah, well. So yeah, Doctor, following up, just make sure you have the logic. The rest of the keyboard still zigzags. Yeah, and that you can take care of in your two little lists there of which keys are correlated to which matrix buttons. All right. Well, I think we're going to cut our losses here before the thing goes back out of sync. Thanks so much for stopping by today. And I appreciate you putting up with wacky AV issues. It's a challenge, and I appreciate you being here for it. So thank everyone, and I will see you next week with another JP's Product Pick of the Week on Tuesday and another JP's Workshop on Thursday. Thanks, everyone, and see you next time. Bye-bye.